Good evening and welcome to Tinkering with Edkelar. Last episode I had the high impedance headphones on my bench. Now these require a matching amplifier if I ever want to use them with my MP3 player. So why not try to design my very own headphone amplifier? To keep it in the right theme, I decided to create a little tube circuit, emulating the final stage of the scope. Since I'm not ready to calculate a tube circuit, I'd need to tune my design by practical experiment. Tubes are a bit complicated though. You need a heater voltage to get them going, and then you need high voltage for the plate and a negative bias for the grid at least. My Philips power supply isn't going to cut it for tubes. This is where my most recent purchase will come in handy. Let me present you the Grundig 6007 lab power supply. It is a well-known device in tube tinkering circles, and I managed to get myself a complete unit. For this project, I think it's proper to introduce the device a bit before digging into it. The 6007 is a linear DC supply with a total of 6 output channels. The two main channels range from 80 to 350 volts at 100 milliamps. The third one is from 50 to 250 volts at 50 milliamps. The current capability is nothing to write home about, but it's intended for tube circuits. They are all about voltage, not current. Keep in mind, 350 volts at 100 milliamps is still 35 watts of output. The secondary channels, each combined with the primary one, provide negative voltage ranges, 10, 50 and 100 volt respectively. All three main channels are isolated, only sharing the ground line with the paired up negative rail. Any combination between them is possible, allowing for up to 950 volts DC at a maximum of 50 milliamps. It also provides common heater voltages, AC in this case, ready to plug in. These devices show up on eBay and other sites now and then, in various conditions. The going rate is anything from a few dozen euro to 600 or 700 euro even. Why is there such a large gap, you ask? I blame certain audio people for that. The 6007 uses two EL156 tubes as the main channels, pass tubes. The main output voltage is from the rectifiers via a choke, that tube, a fuse and a switch, and maybe a current shunt. No other components is in the output path. These tubes have to be beefy, and the EL156 has become very popular with the retro tube amplifier crowd apparently. Matched pairs of these go for as much as 500 euro, which means a complete 6007, including the tubes, is usually over 500 euro, one without the tubes well below 100, depending on the other state. This particular one is complete, but it has a problem with the second meter. It seems to be physically stuck. The button to switch it from voltage to current also is busted off. Some repair needed. After winning a for pickup only offer on eBay that was needlessly complicated by a bug in their website, I managed to get this unit on my way around Germany in early September. Pickup only was understandable since the device weighs in at a back-aching 24 kilograms new, or about 25 kilograms today, including some rust, dust and nicotine. On the inside, it is already clear just why it is so heavy. There are 4 chunky transformers mounted in it, one for each of the channels and one for the external heater voltages. The third, slightly less powerful channel doubles as the heater supply for the internal tubes. I carefully removed the tubes and set them aside first. I don't want to have to replace those. They are held in place with little spring-loaded caps. Interesting idea. The case works pretty much like the RT3 I restored previously. It just drapes around the chassis and clamps together with the outside screws. I would have expected that chassis might be a bit more firmly attached to the handle, but no. All 24 kilograms are held up by the sheet metal and 4 tiny M3 screws. The plastic plate that has the voltage selection and fuse holders is snapped in half. Clearly, somebody has put down the unit on its back and busted it. Might have been me, I can't recall if it was like this when I got it. At any rate, it needs fixing. The chassis is connected to the front panel components with a set of loomed wires, just barely long enough to put the parts next to each other for servicing. After exposing all the parts, I remove the broken meter to check out what's going on. Yes, stuck. But the needle looks fine, so there must be something wrong on the coil end. The cover comes off with a minor fight. There are 2 glue spots on the side, and by slightly bending the beveled edge outwards, I could liberate one side and lift off the lid. These meters are moving coil ones. That means that the coil is on the moving part with the pointer and rotates inside the magnetic field. They seem to be very high quality. There is a cup that encloses the coil section like a sleeve. It can be moved along the axis with a screw in the back end. This is clearly a way of fine-tuning the magnetic field to get the precise calibration of the current to deflection ratio. Awesome! And this little metal sleeve is what is causing the problem. Apparently, some time ago, the carrier which is supposed to hold it in place has deformed, and it was getting pulled onto one side with the magnets and resting against the coil. No wonder it wouldn't move. The fix is to very gently bend the carrier into shape. Now everything moves freely again. The meters also have a mirror behind the scale to avoid parallax errors. These, however, have a strange damage. It looked almost like a very early onset of mold near the edge of the mirrored area, but under magnification it proved that the chrome surface was flaking off. Since any attempt in cleaning was making them look worse, I decided to replace the reflective plates with the shiny aluminium sheet that I used for my Unigor project. No clue what would cause that just at the edge of the cutout. Those parts are held together, so it couldn't be vibrations during transport. Maybe a chemical reaction with the white paint? And since all 4 meters show that ugly pitting, times 4. I also take measurements of the broken button to make a replacement in OpenSCAD. I still need to stock up on decent plastic material for the lathe, but this will do. The front panel is made up of an aluminium cover plate and the structural part. Some screws are sandwiched between them, so in order to take them apart for fresh paint and cleaning, all the buttons and banana plugs need to come off. I was wondering just how far I should go with the disassembly. The wiring looks fine, the transformers are okay, but everything is really dirty. The device was introduced in 1955, so the dirt and dust is to be expected. Also, the yellowish layer over the entire thing is probably nicotine residue. I decided to strip everything, keeping as many solder connections in place as possible. The tube sockets are riveted. I need to drill them out and replace the rivets, cause I sure don't want to remove all the wires. The chokes were held in place with bent over straps, half of which were also soldered to the chassis. Two of them had considerable rust on the laminate sheets. These need fixing. The chassis was a bit bent, so were the pegs that hold it in place. I wonder if that thing had a bit of a tumble in the past. The case gets a quick sanding and a fresh coat of paint. The main filter caps tested okay for capacity, but half of them failed the leakage test. And so, replacing the lot. The case doesn't have much space left, so I do the usual gut and replace method. The chassis gets a good scrub with IPA. lots of yellow gunk cleaned off from that. But it would also take off the labels of the tubes and trimmers. So I carefully cleaned around those. A few yellow patches around the labels is preferred over lost marking, I'd say. The device contains 9 rectifiers. This puts it in the more modern range of tube equipment, but these packages are, to the best of my knowledge, selenium rectifiers. These have a rather nasty type of magic smoke and tend to release it in copious amounts. I consider keeping them, but the prospect of filling my office with foul egg smell made me get a few new ones. I added a bit of thermal paste to the rectifiers because those usually get a bit toasty, but used the old mounting brackets to strap them down. The new ones are quite a bit smaller though, so I had to extend almost all the wiring. Since the rectifiers are nested deep inside the chassis, they needed to go in first. The chokes are second. Followed by the transformers. Connecting the wires was, well, interesting to say the least. The way that the heater transformer is connected means that the wiring on the primary side is polarized. If you misconnect it, the 110 volt setting would essentially nullify the primary. The main switch had screws. I cleaned it. The front panel potentiometers were feeling uneven, so I cleaned them. There was quite a bit of soot on the wipers. I tried to clean the trimmers too, but they are hard to take apart and were surprisingly clean. so I only did one and left the others alone. The capacitors go in next. For most of them, I could find one-to-one replacements that fit into the case just fine. But the filter caps for the third channel are not available in the voltages and form factor needed. So I decided to double up the only ones I could find and create a cap pack. To protect the most expensive tubes, I put in all the ones for the third channel first. Powering up. Okay, seems to work. But during the tests, something went poof. Whoops. Just by the feel, I could tell that my capacitor package was at fault. Turns out that one pair of parallel caps blew up. The polarity is correct, but it seems that the voltages didn't quite even out across the series part. Ordering replacements from the US, which I won't have to double up. I was hoping to avoid the expensive shipping. And yes, it works. The third channel regulates and provides proper output voltages, populating the other two channels. But during the tests I realized that the current metering doesn't work at all. Turns out that the toggle switch is so dirty that it didn't allow for the minute current to pass. Note that the meters peg at 300 microamps. And with the replacement capacitors properly added to the chassis, I can finally set it upright again. Careful when propping it up like this, the tallest capacitor will get bent unless there is something holding up the transformers. Adding the tube caps again. And just for reference, the larger tubes don't have these because there's a little pad on the back cover, which suspiciously looks like asbestos. Better not disturb it. That stuff is only critical when particles come off, so as long as it remains as is, it's not a problem, whatever material it really is. I needed to tune the trimmers slightly. The voltage range was a bit out of spec and two of the channels had a dead range at the bottom edge. Not that I mind a bit more range, but it should not peg the needle on the meter at least. Closing the case is the last step. Not as easy with the weight of the thing. And that's it. I now have a working high voltage power supply to do some tube experiments. I hope you enjoyed this project. See you next time! The 6007 uses EL156 tubes as the main two. The 6007 uses EL156. The 6007 uses two EL156 tubes as the main channels, pass tubes.